The objective of these sessions and these lectures is to help you understand how exactly we can leverage the power of statistics to solve business problems. So we will be not covering so much about a particular topic to its depth, or maybe I would correctly state it like we will not be talking about a certain topic very mathematically, but we will focus more on how to implement it and to solve it, how to use it to solve a business problem. So that is what we are going to do in this session. Now, let me first of all help you understand what all we will be learning in this entire course. So we'll be starting with number one is your descriptive statistics. So let me just quickly. So number one is descriptive. Second is inferential. Third is hypothesis. And fourth is A/B testing. So this is what we are going to cover in this entire course. As I've told you before also that we will not be taking a deep dive of the mathematical concepts, but we will focus more on understanding why we should learn it and how this can solve a business problem. So let's start with the very first problem, which is your descriptive statistics. Now, this is not a problem, but this is basically a technique or a particular topic in your statistics domain. Let's take one simple example to understand where exactly we need descriptive statistics. Let's say we have a data. In this data, we have ID, we have name, we have age, and let's say finally we have marks. And assume that this data is of 1 lakh students. So here, each row which you can see on my screen belongs to a particular student. So let's call this as S1, S2, S3, S4, S5, and so on. Then let's say X1 lakh. So we have 1 lakh data points, basically 1 lakh students, the data of 1 lakh students. And now I want to explain this data. I want to, maybe let's say I want to describe this data. Describe this data. But describe the data to whom? Maybe you want to describe the data to yourself, right? Because if this data is given to you, the very first thing that will come to your mind is what pattern, or maybe what is this data all about? You need to understand the data, right? So before you can do any kind of analytics, before you can do any kind of modeling, and I'm using some great heavy jargons right now, before you can do machine learning, before you can do artificial intelligence, the very first thing is that what you need to do is to understand the data, right? So you need to describe or understand this data, right? Now, maybe what questions you might ask? Maybe since you want to understand this data, you might ask number one question, how many students are there? So we already know the answer, it's around 1 lakh. Second is, what's the maximum and the minimum age? That's one of the question, right? So because you want to understand the range, what is the minimum and what is the maximum age? Similarly, what's the max and min marks, right? That's another question that you might ask. So how we can answer these questions? Now we need some kind of technique, we need some kind of metric to answer these questions, right? So now we have some set of questions and now we are looking for answers. Looking for answers. And we also know that why we are asking these questions, because I want to understand the data. I want to describe this data. So I want to understand the data or I want to describe the data. And that's the reason I have asked these questions to myself. But how to answer these questions? Where to look for the answers? So we have the data with us, right? So this is our data. But if I want to find the answer from this data, I need some technique, right? So that is where your descriptive statistics, descriptive statistics. So let me just quickly change the spelling. So statistics will play a very important role. So that is where we'll be using the descriptive statistics. So descriptive statistics, if you carefully observe the word, it's descript, which basically means describe. So descriptive statistics is basically um, the branch of statistics that helps us to describe the data, right? Let me take one more example for your better understanding, and then we will learn about what all we can or what metrics we have in descriptive statistics. Let's say this is a data, again, the similar data: ID, name, age, and marks. Again, we have few rows. Let's say we have the data points. So student 1, student 2, student 3, student 4, and so on till student. Now let's say I have some 100 students. Now I have the data of 100 students, and let's say this is you. So this is my class in charge. Now the class in charge wants to explain the data, wants to present the data to the principal. So this class in charge wants to explain the performance of the class to the principal. So explain the performance of the class to the principal. Now one way is the class in charge talks about each student and discuss each student with the principal individually. So one approach is discuss about each student individually. Second is we summarize the entire data into few numbers and then present those numbers to the principal. So second approach is summarize the entire data into few numbers and present those numbers to the principal, right? Now, I want all of you to pause the video and just think about it. If you were in the place of the class in charge, which approach you would have taken? I know that most of you would be selecting or going with option number 2, right? Why? Because I have the data of 100 students and I cannot discuss about each student with the principal. Number one, it will not make sense. Number two, it will not get the principal the collective information because the principal is concerned about understanding the overall performance of their class. The teacher or the principal is not concerned. I would not say it is he is not or she is not concerned. I would say when it comes to principal, it is important for the principal to make sure that the entire class is performing good. So the discussion of each student, the class in charge discussing each student with the principal will take a lot of time. Additionally, it will not get the principal the overall or the entire representation of the class to the principal, right? That's the problem. Now, if we go with the second approach, since we are summarizing the information, since we have skewed the information into few numbers, and if I present these numbers to the principal will be able to understand what exactly is the performance of the class without going into the depth of the data, without going into each row, without discussing each row. The teacher or the principal can understand the overall performance of the class, right? So that is where we need descriptive statistics. So what descriptive statistics will do, it will help us to summarize this data and describe this data, summarize this data into few numbers which can explain the entire data without going to each and every row or the details, right? Now, so what I have said is descriptive statistics will summarize the data into few numbers, right? So that basically means if I present the entire information in a pipeline, this is your data. Now, if you apply descriptive statistics on top of it, you will be able to get few numbers. And these numbers are able to explain the entire data, can explain the entire data, right? So what all these numbers are and how we calculate them, that's the second question, right? You must be thinking about it. Number one is what all these numbers are, question mark. Second thing is how to calculate them from the data, right? So if I can answer these two questions, that's what exactly we need, right? So let's start with the very first thing, what all these numbers are. And then we will talk about how to calculate them. But before we jump into this section, basically what all these numbers are and how to calculate these numbers from the data, let's quickly look into the data first. When we talk about a typical data would have two kinds of column. When I say column, I'm talking about a particular column in your structured data. Now, again, I will not go into what is structured, what is unstructured, but anything that can be fitted into rows and columns, rows and columns is your structured data. So when you're talking about structured data, we are talking about columns. So let's call this as call 1, call 2, call 3. So when you have multiple columns in your data, all these columns can be divided into two buckets. Number one is numerical and non-numerical. Now, guys, please understand, I'm oversimplifying thing right now. If we talk about the exact jargons, or if we talk about the exact terms that are used for these columns, it is qualitative and quantitative. But since our focus is not to go very deep into what qualitative is, what quantitative is, let's stick with numerical, non-numerical, but because it is easy to understand. Or maybe I can introduce what is qualitative and what is quantitative, and then we can proceed, right? Because again, the objective is not to go into the depth of the topic, but to understand its application. So let's understand what is qualitative. When we talk about qualitative, as the name say, like if you read the word, it says quali means quality. So any column that explains the quality of someone is qualitative. Any column that explains the quality of something, right? Now, I hope you guys will agree that quality cannot be a number, right? So I am good, I look beautiful, this class is amazing. So these are the qualities, and qualities are always non-numerical. So qualitative variables are essentially your non-numerical features. Now, the counterpart of this is quantitative. 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 If you focus on the words, it's quantity. Quantitative means something which is describing the quantity. So any column that describes the quantity. Now, again, since quantity cannot be in non-numerical, it should be numerical, right? So let's say if I say my weight is 80 kg, so 80 is a number, right? It's a quantity. Or maybe my mother has asked me to bring 1 liter milk, so 1 liter is a quantity, right? So quantitative variables are essentially your numerical variables. Now, these two terms are very widely popular in the industry. That's the reason. Just keep them in mind, that what is qualitative and what is quantitative. Sometimes someone will ask you perform the qualitative analysis. So they are not asking you to go into the numbers, but they are asking you to go through the non-numerical data and find out some non-numerical metrics. For example, what is the sentiment of a person? That's a qualitative measure. While quantitative are those metrics that are derived from the numerical data, because it is quantitative. Okay, again. So when we talk about any typical data will have either numerical, non-numerical. Numerical is quantitative, non-numerical is qualitative. Very simple. Very good. Now, when we have quantitative data, which is numerical data, then, so I'll just put quantitative, and in bracket, I will also write numerical. So when we have quantitative data, which is a numerical data, I can summarize this data using what is known as measures of central tendency. Measures of central tendency. Now, again, this is the part of your descriptive statistics. So when we talk about descriptive stats as a whole, measures of central tendency is one bucket of metrics. Now, measures of central tendency will have 3 metric: mean, median, and mode. What is mean, median, and mode? You must have heard about this. You must have used it. You must have calculated it. But let's understand what exactly it is. Let's say that this is the data of all the employees that works in a company. So this is the salary data of all employees in a company. Now, in this data, I hope you will find out, I hope you will agree that, so let's assume this is a minimum salary, this is maximum salary. Now, I hope you guys will agree that out of all the employees and their salary, some of them would be in a very low range, some of them would be in a very high range, while most of them would be earning in the mid range. So let's say employees with very low salary. This is so employees with very high salary, and these are the people with um, neither low nor high, right? Now, if I ask you that you need to choose a salary in this entire range that can be used as a representative of the of everyone. So my question is, choose a salary, choose a salary from this entire band that can be used to represent the entire salary range. In simpler word, I'm asking you to choose the leader, but that leader will be representing the entire salary band. So let's say if my salary is 10,000. So now if I need to explain that the salary of this particular company is something, I will be using my salary. I'll be saying it is 10,000. So the typical salary is 10,000. That is what I will say. Now, if you guys, if you try to answer this question, um, some of you some of you would maybe most of you would say that we should go with a salary that is on this part, which is the middle part. Because if I go with a salary, if I choose in any salary from this range, which is the low range, I am being partial, I am being biased the people who are earning high salary. If I choose something from this bracket, I am being partial to those people who are earning on the lower side. So to be to be unbiased, I will neither go on the higher side nor on the lower side. I will be in the middle, right? So I'll go with the middle salary. And this middle salary will now be used to describe the entire company. So we will use it to describe the salary of the entire company, right? So this middle salary, since we are focused to find out middle salary, this the measures to find out a middle value is known as measures of central tendency. That's the reason the term central is used. So when we talk about measures of central tendency, measures of central tendency, we are basically trying to find out the middle value of a data. Middle value of a data. And when we talk about a data, I'm talking about a column. And as we know that the column can be either qualitative or quantitative, since we are talking about a central value, we'll be using the numerical columns as of now. So we have to find out the middle value. But how we can find out middle value? How to find? Now that is where your mean, median, and mode will come into picture. Okay. I hope you guys are enjoying it. If not, just take a pause, have a cup of tea, come back, and we will continue, right? But I hope the ideation is clear and my writing is great, right? Okay, great. Now, what is mean? Let's talk about mean. Now, when we talk about mean, it is also known as average. Average. So let's put some random data, and I will be using my calculator. You guys can use calculators. Let's say this is a class, and I'm asking everyone in the class to tell their age. So here we have students. Let's say these are the students in the class, and I'm asking them tell their age. Tell the age. Let's say these are the results. So student number 1 said my age is 18. Someone said my age is 21. Someone said my age is 17. Someone said my age is 23. Someone said my age is 21. Someone said my age is 18. Someone said my age is 21. Someone said my age is 22. And someone said my age is 25. Then 22. And then 21. And then let's say 19. And let's say 28. Let's say this is my data. Now, how to find out the middle value? Well, if I use the approach of average or the mean, it is given as, first of all, I'll write the formula. So the average, and let's call this list or the data as X. So average is given as summation of xi divided by n. Now don't worry about the complex mathematical expression. It is just taking the sum of all the data points dividing by the number of data points. So I can write it in a very simple way. Um, Sum of all data points divided by number of data points. So this is what your average is. Let's calculate it. So I'll be using my calculator. You guys can also do that. So 18 plus 21 plus 17 plus 23 plus 21, and I should scroll it. Then 18, then 21 plus 22 plus 25 plus 22 plus 21 plus 19 plus 28 divided by what is the value of n? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Divide by 13. We are getting 21.2. 21.2. So now how I can utilize this number? I'll say, and let's say if I have to explain someone about the typical age of my class. So I'll say the typical or the most popular or the most common age of my class is 21 years or 21.2 years if you want to be very specific. Okay. That's what your average is. But is this the actual middle value? The question is this value the actual middle value? Let's see. Let's see. Now what I'll do, I'll take a very simple approach. I'll arrange the data in ascending order. Number one is arrange the data in ascending order. So how it will look like? What is the minimum value? Minimum is 18, I think. Yes, 17. 17, comma. Let me put a cross on. Maybe let's put a cross. 17. Then we have 18. Then we have 19. Then we have 21, 21, 21, 21. So 21, 21, 21, 21. Then we have 22, 22, two times. 22, 22. Then we have 23. And I think 18 were for two times. So we haven't written it. Okay, let me quickly. So we had 18 for two times. So 18, comma 18, and then we were having 17 also. So we can cut this 18 also. 22 for two times. 122, 222 over here. Then we do not have 23. We have 23. We have cut it. So 23. We do not have 24. We have 25. And then we do not have 26. We have directly 28. So this is my data in ascending order, right? Now, I need to find the middle value. So we have 13. We have 13 entries, right? So if you have to find out the middle value, 13 values are there in total, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 13, if I divide it by 2, it will be 2 times 2, 6, 12, then 1, then 0.5. Something 6.5 will come. So 1, 2, 3, 4, 5, 6. And this is the middle value. Then 1, 2, 3, 4, 5, 6, 7. Now 6.5 is the middle value. That basically means it's not over here. It's not over here, but it is actually the mid of these two values, right? So we have 1, 2, 3, 4, 5, 6 over here. 1, 2, 3, 4, 5. Oh, okay. No. That's the seventh value, I think. So 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, and this is 6. So this is the middle value. This is your middle value. Okay. Now, this value is 21. This is the actual middle value. But the average or the mean that we got is what it was 21.2. Now, can anyone think about it? Why it was 21.1? Why it was not 21? Because mean and median both are talking about the same middle value. So when we talk about mean, median, or mode, all these three metrics, they're actually talking about the middle value. So when your mean and median are talking about the middle value, why there is a difference in the answer? Now, there is a very logical answer to this. It is because of this value. It is because of this value. Now, what is this? This is your outlier. Now, there is a new term I'm introducing right now, outlier. So outlier is any observation in the data which is very far away from the majority of the data. So let me just write down the definition. Any data point that is far away from majority of the data. For example, if I try to explain it in a very layman way, let's say right now we have a class. And let's say in this class, everyone is between age of 18 to 21. But there is one particular student whose age is 28 or let's say 30. So this particular person is your outlier. You can understand outlier with another example. So let's say there is a room, and in that room we have all the employees, but the CEO or the founder will be an outlier in that room. Why? Because his salary or her salary is exponentially great or different from all the employees or majority of the employees. So among all the employees, someone will have a low salary, someone will have a high salary, most of them will have a median salary or middle salary. But your CEO or the founder will have a salary, will have an income which is very great or very high compared to everyone in that room. So if Mukesh Ambani comes and join us in a party, he will definitely be an outlier in terms of everything because he is famous, he earns very high, so he is going to be an outlier. So in your data, any data point which is very different from majority of the data is your outlier. Now outlier can be on either side. Right now in our example, it is on the higher side, but your outlier can be on the lower side also. That's completely valid. So it can either be in any of the extreme end, either the extreme high or the extreme low, but any of the extreme end. So outliers can be any of the extreme end, right? Now, what is the impact of these outliers on these metrics? Let's talk about impact of outlier on average or mean. Impact of outliers on mean or average. Now, whenever there is an outlier, so assume that this is your weight balance. Now, if your outlier is on this side, this is your outlier, the red ball is your outlier, then it will pull the mean towards it. So as an ideal state, your mean should be over here, right? This is ideal mean. But your outlier is on the higher side. So let's say this is low and this is high. So your outlier is on the higher side. So what it will do, it will pull your mean will be pulled towards the outlier. So your balance will go like this, right? And your mean will be shifted towards the outlier. Let's say the mean is now over here. This is your new mean, right? So your mean is shifted towards the outlier. Now, if you have outlier on the lower side, so let's take the scenario like this. This is your weight balance, and your outlier is on this lower side. Then it will shift the mean towards the lower side. So your mean will shift over here. This is a new mean. Whereas your ideal mean should be over here. Ideal mean. But this is your shifted mean. So the problem with average as a metric, when you talk about mean or average, the problem is that this metric is influenced by the outliers. So influenced or impacted by the outliers. And that is the reason we prefer using median, because when we talk about median, we are looking at the middle value. We are not considering the entire data, right? So if you look at the process of calculating median, so this is your median. The process of calculating median is independent of the data, right? We are not summing up the data. We are not dividing it with something. We are just picking the middle value by arranging them in ascending order. So since the process of median is independent of the data, the process of finding median, the process of finding median is independent of the data. Median is not influenced by outlier. Median is not influenced by the outlier. So whenever your data comes with outlier, we should prefer using median, not the mean. Now, what is mode then? So guys, don't worry about when to use mean, when to use median, how to find out how to find out outliers. We will talk about it. So I will have a discussion regarding how to find outliers also. So don't worry. But let's focus on the third metric, which is mode. Mode is very simple, straightforward. This is observation with highest occurrence. So if there is observation whose frequency is really high, that's the mode of the data. So if I go back and look at what is the mode, that is 21, 21, 21, 21. So 21 for 4 times, that's the highest frequency. So your mode will become again 21. So in any ideal scenario, any ideal data, when I say ideal, I'm basically saying the data which is free from outliers, free from outliers, your mean will be approximately equal to median, will be approximately equal to mode, because all of them are the measures of central tendency. So all of them would be same or approximately same. And if it is not the scenario, then definitely your data comes with outlier. Okay. So we have talked about the three measures of central tendency: mean, median, and mode. But there is still a problem. Have we defined the entire data? So if I go back and look at this data, is it possible to define the entire data just by using mean, median, mode? Is it possible to define the entire data just by using mean, median, and mode? Well, it is not. So we need more such measures, right? But as of now, I believe you guys are clear with the three measures of the central tendency, which is mean, median, and mode. Let's talk about the next topic, but we will take a small pause. Hello, guys. So in this particular video, we will talk about measures of dispersion. Now, I hope you guys remember that in the last video, we talked about measures of central tendency, which were your mean, median, and mode. So we also learned that mean, median, mode are not enough to describe the entire data, right? Because these are the measures of these are basically your descriptive analytics or descriptive statistics, and mean, median, mode are not enough to describe the entire data. Now, why? And why we need measures of dispersion? So let's talk about it. Now, you can see that this is a sample example that I have created, and this is best example to understand the need of measures of dispersion. Here you can see that the marks for math and the marks for uh, English, the average marks are same, right? 53.3, 53.3, both are same. But if you closely observe the marks for math and the marks for English, you will find out that they are different. Now, looking just at average, we cannot decide or we cannot declare that the performance of the students in both the subjects are the same. And you can see that like 53.3, 53.3, the average is same for both the subjects. But when you closely observe each point, each marks, you will see that there is a difference. Let's try to plot the marks. So here, I'll quickly draw. So let's say here it represents a student ID 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's say here, so I'll use a green color. Let's say this is 53. So this line is the average line, which is 53. I'm using 53 as of now, rounded off. Now let's plot each point. So for 1, the marks were 27. So it will be close to over here. For 2, it was 52. So very close to here. Then 48, 48 maybe somewhere around here. Then 33, somewhere around here. Then 39, little bit up. Then 39 के बाद है 65, so maybe somewhere around here. 82, somewhere around here. 88, so 88, little bit up. 23, very down, and 76, somewhere around here. Now these are the distribution. I would say the scatterness of the marks around the mean. So this is scatterness of the maths marks around the mean, right? Now let's do the same thing for English. So just doing the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's assume that again the average is over here. So this is 53. Now let's plot. So first is 55, little bit over here. Then 54, again over here. 58, little bit on this side. 59, 51, 52, 57, no, 48, 58, 49, and 49. And let me just change this. Let's increase it a little bit. 53. Now, if you closely observe, the scatterness of the marks for math is really high, while the scatterness of the marks for English is really low, right? So, here, if I compare just the mean, so if we compare just the average of the two subjects, I will be making a wrong decision because just looking at the average, I will declare that the performance of the students in maths and the English subject is the same. While if you look at the scatterness of the marks after plotting it at what we have done right now, you can see that there is a great difference. Now, if I can somehow quantify this scatterness, I will be able to get a more clear picture regarding the performance of the students in specific subjects, right? So next objective is how to quantify the scatterness of the data points around the average, right? This is what I want to do. So basically, I'm interested in finding out this distance, then this, then this, this, and this, this one, and this one. So can I quantify these distances? Because if I want to quantify the scatterness, I can basically find out these distances and then I can somehow take the average of it or maybe add them to get a number that defines this scatterness around the average. So let's do it. Let me quickly get the data again. So I'll just add the image again. Over here we have the image. Oh, now let's create one more column. And here I will calculate the distance d, which is nothing but your data point. Let's call this as x, and let's call this as x average. So this will be x minus x average. And let's just let me just create the table. And I'll be using my calculator. You guys can also use your calculators because if you do it along with me, you will be able to learn it, understand it much faster, right? So I'll be using my calculator. What we need to do is just subtract 27 minus 53. Here, 52 minus 53, 48 minus 53, 33 minus 53, 39 minus 53, 65 minus 53, 82 minus 53, 88 minus 53, 23 minus 53, 76 minus 53. So I'll be using my calculator and we'll put all the numbers. 27 minus 53, that's minus 26. 52 minus 53 is minus 1. Then 48 minus 53 minus 5. 33 minus 53 is minus 20. 39 minus 53 minus 14. 65 minus 53, 12. 82 minus 53, 29. 88 minus 53, 35. 23 minus 53 minus 30, and 76 minus 53, 23. Now, just give me a second. Okay. So now I want to get the summation of it. I want to get the total somehow. So we have found out all these distances, right? This D, 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 and so on. Now I want to consolidate them. So the way to consolidate them is to take the average of all the distances, right? That is what we can do. But there's a problem. If I just take the average of all these distances, now since this D comes with both positives and negatives value, your positives will cancel out negative. So positives will cancel out negative, right? So that will be a problem. Now, one way to solve this problem is you take the absolute value of the distances. The another way to solve this problem is to square it. Mathematically, taking a square is a better option. Now, there is a reason behind it why I should go with the squaring the values rather than taking the absolute. So, those of you who are from the mathematical background can recall that your square function, which is x square, is basically a continuous function, while your mod function, which is the absolute function, is a non-continuous function. So that is the reason mathematically it is always preferred to take a continuous function because it is easy to optimize. Now you guys don't need to worry about it because as of now we are just trying to understand how these measures, which is the descriptive measures, can help you understand the data better. So as of now, please don't worry about what I just told you, which is continuous and optimization. That's something you guys can ignore. But the reason we are going with the squaring these distances and going with d square is because it helps the it helps the mathematical function to get optimized easily. So there is a mathematical reason behind why I'm going with d square and why I'm not going with the mod of d or the absolute of d. So please don't worry about it. There is a reason. That's the reason we are going with d square. But again, let's use our calculators and let's quickly find out all the squares. So we will find 26 into 26, which is 676, 125. Then you have 14 into, sorry, 20 into 20, which is 400. Then we have 14 into 14, 196. 12 into 12, 144. 29 into 29, 841. 35 into 35, 1225. 30 into 30, 900. Finally, 23 into 23, 529. Now I can take the average of this d square. So the average of d square will be summation of d square divided by n. So let's do this math also. And 676 plus 1 plus 25 plus 400 plus 196 plus 144 plus 841 plus 1225 plus 900 plus 529. So this comes out to be 4937 divided by, we have 10 observations. So dividing it by 10, I will get 493.7. Now this is what we have obtained. But what is the meaning of this? What actually it means? So this value is basically the average squared distance from the mean. But I hope you guys will agree that we humans cannot interpret square values, right? So to make it more interpretable, so to make it more interpretable, we will take a square root of the average of d square. So I will take a square root of average of d square, and that will come out to be, if you guys are using your calculators, you can quickly help me with the value. So a square root of 493.7, that's 22.2. So this is basically your average distance from the mean. So on an average, a particular data point is 22 units above or below the mean. And this is known as your standard deviation. So we have learned about two things. One is variance. So variance is what was this value? This was your variance. So variance is given as summation of x minus x average, which is distance, the whole square divided by n. While standard deviation is given as the square root of summation of x minus x average to the whole square divided by n. So standard deviation is something that we human can interpret, we human can understand, while variance is something that is difficult to understand, right? So that is the reason we use standard deviation more frequently than the variance. Now I will ask all of you to also find out the standard deviation of English marks, and I'm not sure with what was the number, but it will definitely be lower than what we have obtained for math. So let's take a random number. The average of the maths marks was found to be 53, while the standard deviation for maths marks was found to be 22. Similarly, the average for English was found to be 53. And let's say, I'm not sure, but let's say the standard deviation for English, let's say the standard deviation for English was found to be, let's say, some 5. Okay. Now, what you are able to understand from these two measures the thing is that you are getting a better visibility about the data. So what we can understand is the average performance, the average performance in both subjects were the same, right? So looking at the average, we can see that the average performance is same, but the point to be noticed over here is the standard deviation. So on an average, uh, the students scored the students the marks of the students on an average, the marks of the students were between 53 minus 22 to 53 plus 22 in maths subject, while for English it was on an average the marks of the students were between 53 minus 5 to 53 plus 5 in English subject. So what it helps us, it basically helps us to understand that in which particular data there is a greater variation. The data points are more scattered, while in which data the data points are more concentrated around the mean. And this information has given you a better visibility about what kind of data you are working with, right? So if I just tell you that the average is 53 and 53 for math and English, there will be an assumption in your mind that the performance in the subject math and English for the students is the same. While as soon as I tell you the standard deviation, now you guys know that in math subject, there are students who have scored really high, there are students who have scored really low also, because the standard deviation high is high, so the variation of the scatterness is also high. So the data is more scattered around the mean. While as soon as I tell you that in English the standard deviation is 5, then you guys know that the standard deviation around the mean of the English subject is low. So students have not scored really high or really low. They have scored more around the average. The data is concentrated more around the average. Let's do one exercise to basically understand how this can be really useful. I'm just taking the example of math, science, and subjects again. So let's say we have three subjects: maths, English, and science. We will look at the mean, we will look at the median, and we will look at the standard deviation. Let's say the mean is 50. And please remember, I'm only talking about 1 to 100. But the range is really important, because if you don't know the range, you will not be able to understand which one is high or which one is low. So the comparison of the standard deviation can only make sense when we have the data points in the same range. For example, right now, the marks of the maths versus the marks of the English were both calculated on the same range, which was the minimum is 1 and the maximum is 100, right? So this is something which you need to be very much sure with, that the range is same across all the columns or all the data points that you are comparing. So range is same across all subjects. Now let's say for math, and I'm just creating some hypothetical data to help you guys understand the usefulness of measures of central tendency and measures of dispersion. So for maths, the marks were, the mean marks, or the average marks were 50. Median was, let's say, somewhere around 48, while the standard deviation was, let's say, 23. For English, the average was, let's say, 88. The median was, let's say, 89, and the standard deviation was, let's say, 10. For science, the average was, let's say, 23. The median was, let's say, 39, and the standard deviation was, let's say, 5. Now just pause this video and try to understand how the performance of the students is described in these results. And I want all of you to spend some time trying to make a story out of the data which I have presented in front of you. Now I think you guys would have thought about it. Let's try to understand it. Now here, for maths, let's say this is my number line. Minimum is 0, maximum is 100, and average is 50. So this is my average marks. But the median is 48. Median is over here, 48. This is your median. Now, what we have learned about the outliers in the last discussion on measures of central tendency. So wherever we have outlier, that is the place where your mean will shift, right? So if my median is on the higher side, sorry, median is on the lower side, but mean is over here, right? Mean is over here, while median is on the lower side. That basically means there must be some outlier value over here, due to which the mean has been shifted towards the higher side. So one point that I can think about this data for maths is there are few students who would have scored really high, right? That is the reason your mean has been shifted while median is at 48, right? So that's the one point we can understand. Now, let's look at the standard deviation 23. Now, since the standard deviation is 23, that basically means on an average, the students would have scored between 50 minus 23 and 50 plus 23. So there is a great dispersion, there is a great scatterness in the marks or the spreadness of the marks around the mean. So there are students who have scored really high and really low because of the standard deviation being 23, and 23 is a higher number when compared with 10 and 5. So what is the range in which most of the student would have scored? So on an average, the or I would say on an average, most of the students would have scored between 50 minus 23 to 50 plus 23. Now, this is a range where most of the student would have scored. I'm not saying that this is the only range in which the student would have scored. No, this is the range in which most of the student would have scored. Is everyone clear? Now, let's look at other marks. When we look at English, the English marks are telling me a different story. Again, let's say this is 0, this is 100, and then the average is at 88. So, average is over somewhere over here. 88. This is my average. While median is 89. So, median is very close to this 89. This is my median. Now, when you compare mean and median, you can see that they are very close to each other. But since your median is greater than your mean is on the lower side, someone would have scored lower. Someone would have scored a little on the lower side, due to which your average has been shifted on the lower side. So there must be someone who would have scored on the lower side. So this is your outlier, right? Second thing is the standard deviation is 10. Now that basically means most of the students are in this range. So 88 minus 10 would give you 78. 88 plus 10 will give you 98. So most of the students would have scored in this range. And that's a great range, right? That basically means the students in the English subject has actually performed really great. Now, when it comes to science, the story is really different. The- Now, when it comes to science, the story is really different. Let me draw the line again. And again, this is 0, this is 100. And the average is 23. So this is your average, 23. The mean is 39. So mean is somewhere over here, 39. While the standard deviation is 5. Now, this is very interesting. The median, this is your median, while this one is your mean. So your median is on the higher side and mean is on the lower side. Now, if my mean has shifted on the lower side, that basically means someone would have scored really low. So you have outliers over here, right? So you have so many failures. While standard deviation is just 5, that basically means somewhere from this range to this range, 27, and this will be your 18. So 18 to 27 is what the range in which a student or most of the student have scored. Now, this is really concerning, right? So if I have to just summarize, I would say that the performance in English subject is exceptionally great. Then we have maths, in which the performance is more of a kind of average. And then we have science, in which the performance is really bad. And most of the students have scored really bad in English and in science. So you can see that how the combination of measures of central tendency, which is mean, median, mode, and measures of dispersion, which is your standard deviation and variance. And I would right now only focus on standard deviation because that is interpretable to us, the humans. So how the combination of these two techniques can help us get better visibility, get better understanding of the data, right? So I hope everyone is clear till this point. Now let's talk about how we can understand the dependency or the impact of one variable over the other. So what I'm trying to say, let's say I have the data regarding the student ID, uh, the number of hours student study, and the marks in any subject, let's say marks. And let's say this data I have for the entire school. Now what I want to do is I want to understand what is the impact, what is the relationship between the number of hours a student study
and the marks a student has scored. Is there any relationship? Is there any impact? That's what we want to understand. Now, how we can do this? Let's try to solve this problem visually first. If I plot this data, let's say we have the data points scattered like this. So let's say these are my data points. Now, let's say this x-axis is number of hours and this y-axis is your marks. Now, I want, if you look at visually, you can understand that as the number of hours increases, the marks are also increasing. So the first understanding that we can get from this plot is as the student spends more time on studies, the marks are also higher for that student, right? Now, the problem is visually we can understand this, but how we can quantify it? Because that is what I want. I want to get a number which can actually help us to get the understanding regarding the relationship, the relationship that we are right now able to understand just by looking at the plot. Can I get some number? Can I get a number that can help me get that understanding without looking at the plot? That is what I want. I want to quantify this information. I want to quantify this information. Quantify this information. So how we can do this? Now, again, the technique is to compare this information with the average. What I'm trying to say is, let's say this is your, this line represents average number of hours. And this line represents average marks. Now, let's try to find out uh, the distance of each data point from both of these averages. Let's call let's call this as y average because this is on the y axis, and let's call this as x average. So each data point is on x comma y, right? So this is on x, this is on y, right? So x average, y average. Now for this data point, my x average and y average would be like this. Let's call this as a, data point a, and this as b, c, d, e, f, g, h, I, and j. So can I do something like this? X a minus x average into y a minus y average plus xb minus x average into yb minus y average plus xc minus x average into yc minus y average plus xd minus x average into yd minus y average, and so on till j, right? So xj minus x average into yj minus y average, and we divide this with the value of n. This is known as your covariance. So covariance means the scatterness between two variables. Co means we are talking about two, and variance means that the variance of the data between two variables is covariance. Now again, this value is non-interpretable. Why? Because x minus x average, let's say this is xa minus x average, so this is some d, let's say dx, and this is dy. So dx into dy will give you some number which is again non-interpretable, right? But it helps us with a sign, and that sign is interpretable. What I'm trying to say is this data point A is below x average, sorry, is below x average. So this is your x average, right? This line is x average. So this data point A is below x average and it is also below y average. So eventually this will be a negative value. This will also be a negative value. So negative into negative will give you a positive value, right? So here I will get a positive value. Similarly, B is below y average and B is below x average. So again, this will be negative, this will be negative, and this will give us a positive value. Similarly, the value C is also going to give us the positive value because both are going to give us negative. So xc minus x average will be negative, yc minus y average will also be negative. So negative into negative will positive. Now in nutshell, also let's talk about this data point h. Now h is above y average, h is greater than x average also. So this difference, so this will be positive, and this will also be positive. So positive into positive is again positive. Now in nutshell, right now, the covariance that I would get for this kind of data would be some positive value, some positive value. Now, I am not sure about what that value is, again, because it is non-interpretable. We cannot understand it, but this is some positive value, right? Now, this positive is what going to help us understand the relationship. So this positive is what going to help us with the relationship. Now, let's draw more cases. So if the case is this, then your covariance is going to be positive. Positive means there is a positive relationship between x and y. So if x increases, it will positively impact y. So x increases, y will increase. If x increases, y will also increase. If x decreases, y will also decrease. So their movement is on the same side. If we are talking about this scenario, x, y, and let's say the data points are like this. Now in this case, you can see that as x is increasing, y is decreasing. So here, my covariance would be negative, some negative value. Again, the value is non-interpretable, so we don't know how to understand it. We will ignore it as of now, but it will be negative. So what is the meaning of that? If x increases, it will negatively impact y. So if your x is increasing, your y will show a opposite behavior. If your x is, let's say, reducing, your y will increase. So this is how it will happen. Now the third scenario is, so this is known as no relationship. This one is no relationship. Now this is a problem with covariance, because in this case, I will get either a positive value or a negative value. But since that value is something which we cannot interpret, I cannot figure out which scenario this particular case falls under, because the value does not have a defined range, right? So this is the problem. Now, how we can solve the problem? That is where the concept of correlation comes into picture. Correlation. Now, what is correlation? In the case of covariance, the formula is summation of x minus x average into y minus y average divided by n. Right? This is what we have done. But here, what is the unit? Let's say I'm talking about this kind of data where x talks about, um, let's say, age, y talk about income. So the unit of age is in years, while income, the unit is, let's say, rupees. Right? So here, this x minus x average will yield the unit as years, because some year minus the average year will give you year only, right? So the unit over here that you will get is year and rupee. So the value that you will get over here will follow this unit. Now, can I get rid of this unit? Can I remove this unit? I hope you guys will agree that standard deviation also comes in the same unit as of the data. So if I find out the standard deviation of x, which is age, the unit will be some value but in years. Similarly, the standard deviation of y will be some value but in rupees. Now, can I use this to nullify the units of the covariance? And that is what correlation is. So in the case of correlation, what we do something like this. Summation of x minus x average divided by sigma x. Sigma x is nothing but, sigma is the representation of standard deviation. So x minus x average divided by sigma x into y minus y average divided by sigma y and divided by n. Now what it has done, it has just nullified the units. I hope you guys will agree that x minus x average will give you unit is in year, YRS years. This sigma x is also in years. Similarly, y minus y average will be in rupees. This sigma is also in rupees. So this will cancel out this will cancel out this. So correlation comes out to be a unit-less quantity. There is no unit and it is in a proper range. So the range of correlation is between 0 to 1. This is the range in which you will find out correlation. Now, what is the advantage? Let's say I have two variables, x and y, and they are scattered like this. Now, for them, my correlation will be a positive value between 0 and 1. Will be a positive value between 0 and 1, and this 0 and 1 will define the strength. So when you have to read correlation, you read it value, sorry, you read it with firstly the sign and the magnitude. So correlation, if you have to read it, you read it first the sign, then the strength or the magnitude. So if for this case, if the value is plus 0.9, so plus means they are positively related, and zero point 0.9 is the strength. So the strength is really high of the relationship. So the strength is really high. Now let's take a second scenario. Let's say the scatterness was like this. Now in this case, your correlation, let's say, came out to be minus 0.9. Now please remember, whenever you read correlation, read it sign and then magnitude. Don't read it in number line. Minus 0.9 is not, you do not have to read it in number line. So here I will say minus 0.9. So minus basically mean they are negatively related. And 0.9 means their strength is really high. So the relationship is negative. As you increase x, y is decreasing. But that strength, that relationship is also really high. That is defined by this number 0.9. And if now we have a case like this, now in this case, you will get a correlation value close to 0. This means no relationship. So this is the advantage. Now using correlation, I have a range between 0 and 1 where the value, if it is closer to 1, that means, or let me write it down. So when we talk about correlation, we have two things. Number one, your sign. Second thing is your magnitude. Now the sign can be positive and negative, and this magnitude can be between 0 to 1. So if the value is closer to 1, that signifies a strong relationship or a strong strength. So 1, 0, if your value is close to this side, this is a strong relationship, and this is weak relationship. And here positive means positively related. Positively related. That means as you increase x, y will also increase. And this signifies negatively related. That means as you increase x, y will decrease. I hope the theory logic, the conceptual knowledge is clear to everyone. So what we will do now, we will look into one example that we will solve in Python, and that will actually help you to understand the application of these concepts. But to just summarize, we learned about the measures of dispersion, where we learned about variance, which was non-interpretable, and then we learned about standard deviation, which was more interpretable, which was talking about the average distance of the data points from the average line, which is the mean. Then we talked about covariance, which was how to find out the relationship between two columns or two numerical values. And then we talked about correlation. Now, since covariance is again non-interpretable, we talked about correlation by making covariance unitless. And that's how we learned about correlation. Correlation, when we talk about correlation, you should always read it as sign and magnitude, where sign can be positive and negative. Magnitude is between 0 and 1. And let's now talk about the application of this concept in Python.